Bismillahirrahmanirrahim. Today we have our sixth lecture and this is about frequency and distributions. You can see a picture in front of you. There are letters. There are letters written A to Z and we are showing the count or the number of appearances of these letters in a certain document. So what is frequency? The frequency is about the number of times that some value appears in the data. You can see here it is written 11945 and it is appeared 3 times. 1196 it is appeared 9 times. So we will understand this concept of frequency and distribution with reference to the example of lecture 5. In the last lecture we have done live coding and we have performed a practical about the understanding of random variables. What we have done in the last lecture, we have rolled the dice once and find the sum of the two faces of the dice, and we have rolled the dice multiple times. Now this time we will proceed from the last practical, and after proceeding from the last practical we will explain you the concept of frequency. So in this results variable we have calculated last time, this results variable consists of the results of two faces, the sum of two faces of the dice which are rolled around 50 times, and we have seen the answer of the rolling of the first 10 times. Now I want to know the frequency. What is frequency? Frequency is basically the number of outcome. You can assume it like this, that if there is a dice and the sum of two numbers on the dice is 8, means 6 plus 2. So I want to know that in the list of result how many times 8 is present. This is known as frequency. Let me visualize it by using the data frame technique. Data frame basically arranges data in a beautiful form so we can see and understand it clearly. So I am writing here results, and in the results I am writing 0, and I want to count the values. 0 is for index and I am writing value counts, and it will tell me that in the list of results how many times the sum came. You can understand it better when I run the output. Okay, and I want to sort these frequencies as well, means I want them to be arranged in an order which can be the ascending order. Okay, so I am using this variable frequency and I am adding a Python function sort index. This sort index will sort them, and for checking all of them I am writing sort frequency. Okay, let me run it and you will understand. So it is saying that you have written result. Yes, in the variable result I have increased s and there is no s in the above variable, so I am removing s, and now I am running it again. You can see the output successfully. What is meant by this output? Just see it clearly. It means that the sum on the two faces is 2, means 1 plus 1. So 2 appears 5 times. Sum on the two faces of dice is 3. This 3 comes 2 times. The sum on the two faces of dice is 8, and 8 appears in the list 5 times. and the sum is 11, and this 11 appears 3 times. This is the frequency on the right hand side, and the left hand side, this is the value of sum. So I hope that you got the better concept what is frequency in case of dice outcomes. Now let us move forward. I want to give you a very excellent explanation. So I want to plot this using a bar graph, and you can visualize and analyze the concept of frequency more clearly. So I am importing the matplotlib, import matplotlib.pyplot as plt, and I am writing sort frequency, the variable I have used above, sort frequency dot plot, and in the dot plot I want to plot a bar graph. So I am writing kind is equals to bar, and color you can choose any color. I can write color is equals to blue, and figure size for proper visualization, so I am writing figure size 7,4, and for seeing this I have to write plt.show, and let me run it. So in the figure size I have made a little mistake. I think it has shows the positional argument follows keyword argument. Okay, let me see what it is saying. So in the figure size I have left equals to, now it is correct, and let us wait, and for seeing the plot I have to write plt.show, and let me run it now, and you can see the frequency plot. The number 2 comes around 5 times, the number 6 around comes 10 times, the number 9, you can see the number on the x-axis. These are the result, the sum of two dices, and on the y-axis you see the number of times they appear while rolling the dice. Now I want to find relative frequency. What is relative frequency? You got the concept of frequency in terms of dice example. Now what is relative frequency? Relative frequency is the frequency divided by number of trials, and now everyone will ask what is number of trials. So the number of trials is the number of times you rolled the dice. Suppose you roll two dice once, in the second time you roll two dice 50 times, you roll two dice 100 times, you perform the practical of rolling the dice 1000 times. So frequency divided by number of trials is the relative frequency. Now moving forward in our practical we will calculate the relative frequency. So let me write the formula of relative frequency here. Relative frequency is equals to sort frequency, which is my variable, sort frequency divided by trial. So I have used the variable trial above. Yes, relative frequency divided by trial, and I am working for 50 trial because the variable trial now consists of 50, the value of 50, as you can see above that I have rolled the dice 50 times. So I am calculating the relative frequency. So let me zoom it out and write the code in front of you. So I will write relative frequency dot plot, and in the plot I will write the same thing I have written above, bar plot. No need to mention the color we have to save time, figure size, and in the figure size I will write 7 comma 4 and plt dot show. Okay, and let me run it. Again I have missed the equals to in figure size. Now this is the relative frequency, uh, the frequency divided by number of trials, and this is the frequency plot we have plotted above, that is about sorting the frequencies. And now this is also the frequency plot, but it is the relative frequency. We have increased the number of trials, means this graph is showing the result after rolling the dice 50 times. Now I want to calculate more relative frequencies. Oh, so more relative frequencies means, what is meant by more relative? Now you can see I am writing the variable trial again, and now in this trial I will do for 100. So this time I will roll the dice for 100, and I am repeating the above process again, the process which I have done above for rolling the dice. So I am going to repeat it because I want you to get in practice and to used to of the things I am doing here. So I am writing the same thing I have written in the last lecture, and today we are calculating frequency, relative frequency of 100 tiles. Last time we calculate for 50 trials. So okay, let me write it here, the list comprehension, and in the list comprehension let me calculate the frequency. So for the frequency just we have made last time, I am again making a data frame for beautiful visualization of data. So I am writing all the things live data frame, and in the data frames I will call the results variable. Okay, and in the results same I want to count the value in order to plot the frequency. So I have written value counts, and now I will sort the frequency again. These are all the same steps I have done earlier, but for your practice and for your better understanding I am writing them again. So frequency dot sort index, sort function, yeah, sort index function for basically sorting the data, so you can see it clearly. Now again using the same thing, relative frequency, the formula of relative frequency is sort frequency, or the frequency divided by, and it is divided by number of trials. Okay, and I will calculate, I will make the plot for 100 tiles, for 200 tiles, for 300, for 5000. So you will get the idea of how relative frequency can be used in the prediction of stock data. So I am finally plotting it using the plot function, and in the plot function I am writing kind is equals to bar, and in the plot function I am again giving a figure size, and figure size is equals to 7 comma 4, and now I want to see the plot, plt dot show. So let me zoom it out and run it so you can see the output. So it has showed me that I have done mistake, just I have done again, I am doing for, I have missed the range function for I in range, which is necessary for the necessary for the for loop. So let me see my mistake and correct it. I have also added unnecessary square bracket, let me remove it. That is the idea of live coding, you will get all the mistakes in front of you. You can see I have plotted my same result for 100 number of trial. Now let's see the magic. Now I am going to do the same step, copying and pasting, but what I am doing right now, I am making this 100 to 1000. So we have rolled 2000 two dices 1000 times, and now see the output. Let me run it. you can see this is the rolling of a dice 100 times. This is a rolling of a dice 1000 times. Now let us move forward and roll the dice for 10,000 times. Okay, and you will see the output. So what is the thing I want to show you with the help of this program? I will keep all the three graphs in front of your eyes, and then you will decide what is the magic of Python. You can see first, here is very first we have sorted the value. This is the value of 50 trials, okay, and we have plotted it. This is the frequency of 50 trials, but we went to the concept of relative frequency. Okay, frequency divided by number of times means we want to roll a dice number of times. So we calculated the frequency, the relative frequency, and we have plotted it. Okay, means this number comes these times. Okay, then we move forward and calculate the relative frequency by rolling a dice 100 times. Then we do it again. We move forward and again calculate the relative frequency. Then now it is for 1000 times, and now then we move again. We copied the same code and then we calculate the frequency. Now this frequency is about 10,000 times, and you can see all these three graphs. These graphs are unstable, means there are values going up, values going down, values going up, values going down. Why? Because we have less number of trials, but everything learns by practice. Yes, then we start increasing the number of trials one by one, and when we increase the number of trials, you can see it clearly that the outcomes of the bar graph are becoming stable. Now this is the concept I want to explain you with the help of this great example. Now read it. Relative frequency will become stable in case of more number of trials, means the relative frequency is always disturbing in less number of trials, but we when increase the number of trials, when we roll the dice for 2 times, for 50 times, for 100 times, for 200 times, for 1000, for 10,000, and for more trials, the relative frequency will automatically become more stable if we increase the number of trials. So first of all, before starting this lecture, I told you what is frequency. The number of times we got the result 3, we got the result 4, we got the result 5, we call it as frequency. And then we told you that if we increase the number of trials and we divide the frequency with the number of trials we have done, we call it relative frequency. And then we made the graphs of relative frequency, and in the graphs what we have done, we have increased the number of trials one by one, and we have observed with our naked eye that by increasing the number of trials the relative frequency become more stable. Now I am going to give you the golden concept about frequency and distribution in this lecture. What if we increase the number of trials? See this from this part. Okay, infinite number of trials. Now you have to listen it carefully and get the proper mathematical concept that why we are understanding relative frequency for models of stock prediction. Let us start.
A limit if we have infinite number of trials. Distribution of a random variable is a table consisting of two sets of values, one for different values of outcomes, the other lists the probability for each value. Here is a distribution table. We can compute all probability for x using Python here. X distribution is the distribution table we built. From the distribution table, we do not know the shape of outcome immediately. Usually, mean and variance are two characteristics of the distribution of random variables. Mean.
Yes, we are going to discuss in the video then what happen if there are infinite number of trials. So there is the need to understand the distribution of a variable on x-axis. You can see your sum of two rolled dices were coming on the x-axis. Now if you want to understand the concept, if you want to understand the idea, you must have to understand how the variable is distributed. And you have studied in the mathematics in your mathematics department about the distribution, the normal distribution, the continuous distribution. So for understanding the distribution of variable, we have to know about the mean and variance. Today is the day in financial maths department that you are going to understand the practical implementation of mean and variance.
Of a random variable is also called expectation. The right side is a general formula for the mean and the variance of a discrete random variable. Xi here is any possible outcome. Pi here is the probability for this outcome. The mean is the average of all outcomes weighted by probabilities. Similarly for variance, which describes the variation of outcome. On the left, it is a Python to compute the mean and the variance given distribution table. What is the distribution for continuous random variables? How to compute the probability for continuous random variable? We will start with the simplest continuous random variable, which has uniform distribution. This kind of variables takes possible values with an equal chance in certain range. Here's the distribution graph for uniform random variable, which takes the values on 0 and 100 with equal chance. The height of the red line is not a probability. It represents the value of a density function, which is applied to compute the probability for continuous random variable in this way. The area under the density curve is the probability. Hence, the whole area between 0 and 100 is equal to 1, because this random variable can only take a value in this range. To compute the probability for x taking value between 20 and 60, it is equivalent to get area with pink color. Here's a summary. For discrete random variable, you can find probability easily by checking the table of distribution. It is more complicated in continuous case. It is the area under the probability density function, in short PDF curve. PDF can take any shape. You should be careful to know that PDF is not probability. Now, let's come back to finance questions. Why we need a continuous random variable? Because the distribution stock daily return is continuous. We know that real distribution of stock return cannot be directly observed, not like the dice game. But do we have any good distributions that can describe the daily return reasonably good?
So we have got the idea for the distribution of stock returns, why we are going towards the idea of continuous random variable. So I request all of you to see this example again and again, the example of the number of trials, and after checking this example, open this video and check the concept. I am 100% sure that you will be parallel to the explaining person of models of stock return and why we are using continuous random variable in models of stock return. So that's all for the lecture of frequency and distribution.